Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm gonna make like a simple leaf. Once again, this is like another effort to do this, but we're gonna do it in a more elegant kind of way. So this is only, of course, one of way you can do this, but there are plenty others. I'm gonna start with a line. File, save as. This is a simple leaf, more elegant. Save it on the desktop. Save. And create a viewer draw, and let's see, let's make it like 6 points line, and then we want to use extrude edges. I think I showed you this before, one of the nodes that almost escaped my radar. So vertices, edges, polygon. Okay, seems to be we are needing the matrices. So if we use matrix in and vector in, so in recent Spreadshop updates, they actually allow you to use a vector plug into the matrices, and it will assume that you want it to use the location, but I like to do it like this, just in case we need the scale and rotations. So yeah, that seems to work. And of course, you know that if you use a random vector and plug into this guy and then give it like count, this is also kind of extrude the edges, but it's looking also into the points. You see, so the points matters more. So if you kind of like want to make like a random extrusion, you can use random vector. Okay, so we have our leaves, and then we have this guy. Maybe we can use scaling. Let's see. Okay, that's contouring the stepping. Let's make a leaf that kind of growing in the x-axis. So this guy should be like in the y-axis. 0, 1, 0. If I'm not wrong, if we use like a random number generator and provide like a sequence of number, in this case we have 6 points, so if we provide this and plug into the y, you should get variations. So that can also be something that we can use as our leaves. The idea here is to generate leaves. You know, we have the spine, the middle point, and we kind of grow the leaves this way, and we want the other side now. So that's the idea. You can do this in many different ways. You can actually just use a mirror probably for this random for the sequence of the vectors. Let me try. So line. Let's have another one. Extrude edges, but we're gonna do it in the opposite way. Vertices, edges. That's the line, the spine, and the output. Let's give it a. We're gonna use the same color for now. Matrix. This guy. Plug into this guy. I wonder if we can just use reverse. Math. Kind of. Actually, vector math. Do we have like reverse project distance angle? Maybe multiply by -1. Okay, that seemed to work. There are many other ways to do this, but this is one of them. Okay, so we have our leaves. This can be also like a flower petal. If we bake it, you will see there's a little bit funny thing happening. You notice that the normal of one of them is actually reversed. if I display back face culling, we can see, okay, this one have the face reverse, so that's not gonna work for us, so we need to reverse. The way to reverse it, in this case, we can use apparently we can use list reverse, because the way I think a polygon face is made up of points, right? 1, 2, 3, 4, for example, and then depending on how you draw the face, I think if you draw it this way, it's kind of the normal is gonna pointing up. If you draw it the opposite way, you get the normal that's pointing down. So if you reverse the sequence of the polygon for this guy, we're gonna have the correct result. Let me display. There you go. It needs to be on level 3. So that's now been fixed. If I delete everything and then bake again, the normal should be correct. Both of them facing the right way. Let me turn on back face culling. Oh, actually, they both are reversed now. I need to reverse the other one apparently. So this should go there and this should go there. So now it's correct. Turn off back face culling. So, but the next thing we want to do, because the leaves currently they are separate objects, we want to join them into one. For that, we can use list join. We have to do it for the vertices and the polygon. So this is pretty simple. Just we have to do it twice. Okay, if everything works correctly, this should just work. Bake, and seems to be working. I don't need to change the level. Don't need to use mix or wrap. We can also do mesh join, just to be 100% sure. And see, previously we have like a 2 data stream. Now we have only 1, so we have successfully joined this guy. But if you also notice, if we subdivide, you can see that they two are still separated. There's one more thing: remove doubles. This guy is always plugged into the distance, vertices and polygon, and the distance. The distance, only the closest points get merged together. You can increase the distance, but you know that's gonna give wrong result. So 0.0001. Bake, and now have a look, and then subdivide. Now they are a single surface. If we go inside, now see the middle points, they are all merged correctly. So we have our leaves. Of course, currently the leaves is a bit weird and ugly. There are some plants that actually looking like that. But let's see. I think we need to use this integer number. Okay, so currently it's random. It's kind of like random design. Actually, can be interesting as well if you think of it. The way the leaves being designed, this looks like almost like an insect character. So I just suddenly got an idea. So this can be for our creature design actually. See, if we change the low and the height, now we have some kind of generator for our leaves. But of course, leaves is not random. You actually have some kind of like curve sometimes. or like a noise. Noise actually can give you like a pattern that's a bit nicer. But let's use functions first. Sine wave. Function ease in. We can use ease in, ease out. So vector. We are only dealing in the y-axis, so that's a nice thing about that. We know we need some kind of input. There is easing, and there is also math function sine wave. So which one we want to use first? Let's use sine, and then use range float at the front. So this guy will work. This guy will work for that and for this. Just to be clear, that's range float. Give a value between 0 and 1, and depending on the count can come from this guy. You notice that we also have stethoscope MK2 now. This can come in handy. Graphical list of 12 items. Type float. So that's nice. That's really nice. For easing 0 to 1, we actually just need to provide a value between 0 and 1, and the result is gonna be some kind of value. I'll show you real quick. So that's linear interpolation. Okay, we know that linear interpolations goes from 0 to 1. We can actually have value that's more than 1, interestingly. So if we change the function here, we get a different like a result here, the curve. This is just like F curve. If you are doing animation a lot, you're kind of familiar with all this terminology. Sine is in, is out, and like a bounce, maybe elastic bounce. They're all should be familiar to you. And we can use this for our leaves if you want. One of them actually give you like proper leaves. That's kind of alright, but really for this case we just use a sine wave. You know, sine wave actually goes depending on the value. You know, you get a sine wave. Sometimes it goes actually under 0. That's not what you want. So sometimes you want to use absolute here. So that's you can use this definitely, and you can always give an add here, add a number. So this is kind of like an overall general additional value. So the leaves never goes under 0, or never goes near 0, depending because of this offset. So yeah, I think I'm pretty happy with the sine wave. You can also give like a multiplier here, I believe, for the sine. Probably the only limitation is the resolution, because the edges only kind of give you one resolution between the original and the last. But I think you can probably fix that using vector interpolations. So vector interpolation is another possibility to design a leaves. Imagine if you have like a line with a couple of dots, and you have another line with a couple of dots. You can have like in between, and then you can just put them together. Yeah, I think that's another way we can do this, but I think this is a bit simpler. So the step controlling the overall leaves, and we also can control the min and max of the leaves until we get the leaves that we are familiar with. So that's controlling the amplitude and stuff. That's kind of alright, except that it's in, looks like in the opposite. Maybe we need to use cosine and kind of move this. Well, I prefer to use sine actually. Just gonna offset the line maybe. Okay, that's pretty decent looking leaves. We can combine everything and turn it into a monad if you want. We can bake it. We know that we don't actually stop right here, right? We can always design some kind of circular, like if we have like a circle and plug it into the matrix. If I'm not wrong, we can just do this. So that's the leaves arranged in the circular pattern, but we just need to, I think, we just need to do that. Remember, we need to do the circular kind of thing. Well, I can't remember at the moment, I think, but if you put a rotation here and then rotate it in the angle, range, float, we can make it circular. Yeah, something like that, you know. For that you have like a pedal, but for what I'm doing, I think I want to do it, make it more like a leaf. So let's make a line here and grow this in the y-axis. Use a rewire x, and we want it to grow up, so we need to probably rewire our leaves so it's facing the right way. So you might need to rotate it as well. X to Y to Z. I'll just use a rotation, I guess. With this guy, hopefully we can have proper rotations. Okay, cool. Yeah, so that's the plan. Kind of like leaves that growing up. I'll hide the edges and the points. Cool, alright. So we have control over the leaves, whether you want it to grow up like that. I think the leaves tend to grow up, and we have control over how many leaves. Of course, leaf doesn't just grow in one side, you want it to grow in another side as well. So for that we can maybe use another rotation. Matrix deform. You can actually do this in many different ways. This is just kind of me trying to improvise a bit. So let's say if you rotate it 180, yeah, this one will not actually work for us. Let me see. You need to kind of flip the leaves. We have a mirror, actually vector mirror. This might actually be the answer for us. So this is transformations, and then plugging into this guy, vertex mirror line. I might need to give this a think first, but okay, the idea is basically we have the leaves already, and I just want to build this kind of thing with the leaves. So left, right, left, right. We can do this in many different ways, of course, but currently we are using this matrix in, and I guess I give a think, and then I'll do this in the next live noding. I think you probably know the answer. Just let me know in the comments down below. Thanks again for tuning into this live noding. I'll see you in the next video.